This is just a quick tutorial to show you a simple trick how to deal with repeating textures. So as you can see here, this field has a simple grass texture, and if you look from it from like larger distance, it's quite visibly tiling. So how to deal with that? Well, the most obvious solution is, of course, to take the material and just make things bigger, yeah, like this. But of course, this has a disadvantage that if you go closer, it will turn into this low resolution blur. So the trick is to make a texture that sort of overlays smaller and smaller versions of itself as you go closer. And I'm going to show you how using material functions, which is another quite underutilized function of Unreal Engine. Okay, so let's make one of those functions, and it's right here. It's called material function. Now this technique I'm about to show you, as far as I know, doesn't have like official name or anything. I called it recursive texture, but it's most certainly wrong name, but I'll just use it here. Okay. Like this. And let's open this function, and as you can see, it has an output, and you can add some function inputs to them. So what I'll add as inputs are 2D texture. So for test, let's add a texture here, or rather texture sample. We'll take the input here and we'll just return the texture sample as a result of this function. Now we can test if our basic function actually is usable. So let's go to our grass material. I'll just return this back to 1, okay? Doesn't matter. And now let's see what happens if I go to content here and I'll drag this function into our material. And as you can see, we have a new function here that takes in a 2D texture and returns something. Well, here let's add a texture object as an input for this function. And as you can see, it basically, this function at the moment works just like basic texture sample. Okay, so I'll just remove all this extra stuff so it doesn't confuse us and set our texture to the grass. And this still doesn't do like anything, it's still just basic texturing. So let's start working on making this multi-level recursive whatever texture. Okay, so what we'll have is 4 layers, all being basically the same texture. And what we'll do is we'll like crossfade them based on distance. So here all 4 layers use same texture, and as an input we will have our texture coordinates. Like this, except for each layer we'll make them different scale. So let's say We'll take this and we will divide it by, okay, so 4, and this will be input for this layer. This layer will be coordinates divided by 16, and this one will be divided by 64. You can of course use more layers, but like for most games or most practical purposes, this is enough. Okay, let's see if it works. So if I change preview to this bottom layer, it should be a stretched version of the texture like this. Very good. So now we need to find a way to like crossfade those layers based on distance between the camera and the pixel. So this is actually quite easy because we already have pixel depth in here. There's also scene depth, but this is for transparent pixels, and this is actually quite useful for creating soft particles, which I will cover in different tutorial. Okay, so our pixel depth is distance from the camera in centimeters, so we can use that to layers or to crossfade between this smallest layer and basically reveal the layer underneath if the pixel is far enough from the camera. So let's do that. So we will be interpolating from this one to this one, and since this is in Android units, we will need to divide it by some number to get some reasonable distance in which it will crossfade. So say that 200 it should start, or rather it should finish crossfading at 2 meters. So let's see what this does. And as you can see, when we're close, it's the small copy of the texture, and as we move away, yes, okay, so here's the problem with this. The problem is that this linear interpolation isn't clamped. So if the alpha is larger than 1, it will sort of start glitching out and basically subtracting the A from B, and we want to prevent that. So we will just put clamp on alpha like this. And now when we compile this, it should work. Yeah, so as you can see, large texture, and as I approach it, it's the smaller one. Okay, so for this particular example, actually, as you can see here, the 2 layers are basically enough. You don't need more, but just for example, let's add 1 more layer. So we will have another layer here, and this one will be, so here. I'll also need to clamp it here. Okay, this one will be fading into into the layer 3, and let's say it will fade at 8 meters. So like this. Sorry about that. I'm just trying to move it to somewhat more convenient location. Okay, here it is. And see if it works. Yes, you can see large copy, smaller, even smaller. No pixelation, no tiling. And now if you like specifically look for this effect, you can see it happening, but in normal gameplay, it's practically like impossible to notice this unless it's like very like structured texture. In that case, it's not noticeable, so it's not like effect that works for just any texture. It needs to be some like noisy something, like for example this grass. Let me show you an example. Say this one is a good example of texture where this trick doesn't really work, like these hexagons, and this one is like very obvious, you can see here. So use it with like noisy grass, rocks, and similar. And finally, why did I use this material function instead of simply doing that straight here? Well, the reason is, of course, that material functions are like basically like blueprint functions. They are reusable. So say I already have this texture here and I want to add a normal map. So I'll just copy and paste it, plug it to normal, and I'll just change texture to a normal map, and it's that simple. You don't really need to like copy paste or like rewrite large section of the function. And even if you have like multiple materials that all use this function, it can be used everywhere. And so you want to add another layer. Of course, if you do that, the change will reflect in all copies of the function. Okay, that's all for this tutorial.